All right, so this next video gets into some more advanced stuff about polynomials, and we're not going to, and actually this intermediate value theorem that we're going to introduce is actually applicable to a bigger set of functions, not just polynomials, but polynomials have two properties that are really, really nice. We don't need anything this strong, but polynomials have these two properties. They're continuous. That's actually really all we need, all right? Polynomials are continuous, and I'm not going to go into a big, precise definition of what continuous means, but just very roughly, it means you can draw it without picking up your pen, all right? So they're all connected. There's no gaps, right? If I'm drawing a polynomial, whatever, I can do the whole thing, whatever it does, without picking up my pen. Whereas like some piecewise function, like this is not continuous, right? I have to pick up my pen. I can't go from here to here without picking up the pen, right? Or like something else, maybe like this. This is not continuous because you have to pick up that pen. So polynomials are continuous. And what that means, right, is that let's say I'm looking at a situation, a graph, where I know that at some point A and some point B, I know, hold on, let's use different colors. If I know we're here at point A and here at point B, because it's continuous, I know that we have to cross the x-axis somewhere between there. Now, maybe it crosses once. Maybe the polynomial crosses 3 times, right? Maybe the polynomial does all sorts of things. It doesn't matter what the polynomial is doing. But if a polynomial is continuous and we're up here and then we're down here, we have to cross somewhere at least once. Somewhere in this interval, we have to have an x-intercept. Somewhere here, we have to have a 0. And that's what the intermediate value theorem is all about. Okay? If you don't know how it crosses, maybe it crosses like the red. Maybe it crosses like the blue. Who knows? But it has to cross at least once. So intermediate value theorem. Henceforth will be known as the IVT, because I do not like writing too much. Intermediate value theorem says, well, it says more than this, but in our class, is the intermediate value theorem for polynomials. If f of x is a polynomial function, and the signs, whoa, that D got really split up. And the signs, not sinusoidal sign, but sign S-I-G-N, signs of the function values at A and B are opposite. Let's pause real quick before we finish. Let's parse this information, right? In this previous example, f of A, the function value here, f of A is positive. F of B, the function value here is negative, right? And it could have worked out the other way too, right? Maybe A was over here and B was over here, and maybe A was negative and B was positive, right? It doesn't matter which one's positive and which one's negative. What just matters is one's on top and one's on the bottom. So if we have a polynomial function and the function value at these 2 points are opposites, then there is at least 1, 0 in the interval from A to B. Little emphasis on at least 1. Could be multiple, like in the blue graph. All right, that's the intermediate value theorem. Let's use it a little bit. Example 7. use the IVT to verify or prove that there's at least one zero in the interval from a to b. Part one, I want you to look at this function, x to the fifth minus 2x. And here a is going to be 1 and b is going to equal 2. So we have to use the IVT. We're using the IVT. So the IVT, to use it, f has to be polynomial, and the signs of f of a and f of b have to be opposite. So these are the two things that we have to check. Is f a polynomial function? Yep. Right? F is a polynomial, degree 5. Polynomial is just the sum of power functions. Good. And then we have to check the signs. Are the signs opposite? At f of a and f of b? We have to check that. So f of a is f of 1. F of b is f of 2. Plug that into a calculator. 1 to the fifth minus 2 times 1. That's 1 minus 2. Negative 1. I'm going to write a giant negative sign here. F of 2, that's 2 to the fifth minus 2 times 2. That's 32 minus 4. That should be 28. That's a positive. 1's negative, 1's positive. You betcha. We have a polynomial. The function value is opposite signs at -1, or at +1 and +2. So the IVT guarantees at least a 0. And that's the logic. In this interval. In the interval for the x values. And we're not going to box this as our answer. Our answer is this whole proof. IVT says if we have these two, I don't know what I'm circling. If we have these two requirements, then the theorem tells us immediately, you have those two requirements, there's at least 1 0 in the interval from a to b. So we check that we have those two requirements, immediately interval, or IVT, guarantees at least a 0. All right, and that's really all there is to it. You could do another problem, but it's the exact same. So let me know if you have any questions, and we'll have more selected homework problems in the next video anyway.